Tonight, we're going to explore a measurement that sounds simple, but is actually one of the most mind-bending concepts in all of science: a light year. You have likely heard this term mentioned in passing, perhaps in a film or a brief news report about a distant discovery. But here, in the quiet of this moment, we are going to look closer at what that word truly represents. This is not something you need to understand all at once. You don't need to remember every detail or calculate any specific figures in your mind. You can simply listen, allowing the weight of your day to settle, and allow your thoughts to drift as we move slowly outward from the familiar comforts of home. To begin, let's start with something familiar. Think of the room around you, the gentle weight of the air, and the way light fills the space when you flick a switch. It feels instantaneous, doesn't it? Our human experience is built upon the idea that light is a constant, immediate presence. But as we step away from the porch light and the street lamps out into the velvet dark of the wider cosmos, we find that light is not just a flicker, it is a traveler. It is a messenger that has been journeying across a vast, silent ocean for a very long time. In the next few hours, we will not be rushing. The universe moves at its own pace, and so shall we. We are going to gently peel back the layers of our own atmosphere and look at the distances that separate us from the rest of existence. A light year is not a measure of time, though it contains the word year. It is a measure of distance, specifically the distance that a single beam of light can travel through the absolute vacuum of space in one Earth year. It is a number so large that our everyday vocabulary of miles and kilometers begins to fail us, losing its meaning against the backdrop of the infinite. As you settle in, imagine the universe not as a crowded map, but as a series of vast, quiet clearings. We are currently standing in one of those clearings. Everything you have ever known, every person you have ever met, and every mountain you have ever climbed exists on a tiny speck within this first, small pocket of space. But tonight, we are going to look past the horizon. We are going to trace the path of photons that began their journey before you were born, before civilizations rose, and even before the Earth itself was fully formed. This journey is designed to be a soft expansion of the mind. As we move from the human scale to the cosmic scale, the small worries of the day may begin to feel less urgent, replaced by a sense of calm, insignificance. There is a strange comfort in knowing how large the world is and how much of it remains untouched and peaceful. You are safe here, anchored in the present, even as we begin to drift across the light years. Take a slow breath, let the silence of the room merge with the silence of the stars, and let us begin our walk into the deep, quiet distance. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. When we think about distance, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. Our brains are beautifully adapted for the world we inhabit, a world of rolling hills, city blocks, and horizons that seem far away but are actually quite intimate. When you plan a trip to see a friend in another town, you think of it in hours spent in a car. When you go for a morning stroll, you think of it in the rhythm of your footsteps and the gentle passage of minutes. This is our anchor. It is a safe, predictable way of measuring the reality around us. For example, consider the simple act of walking. A kilometer is a distance most of us can visualize clearly. it is roughly 10 to 12 minutes of steady movement. If you were to set out on a walk today and continue until the sunset, you might cover 30 or 40 kilometers. You would feel that distance in your muscles. You would see the landscape change slowly from one neighborhood to the next. This is a scale that makes sense. It is tangible. If you were to walk across an entire continent, it would take you months of dedicated effort, a journey that would define a significant portion of your year. But as we begin to look upward, these human measurements start to feel a bit like trying to measure the depth of the ocean with a teaspoon. To understand a light year, we first have to realize just how much room there is in our own immediate surroundings. Let's look at our own world, the Earth. It is approximately 12,700 kilometers in diameter. To us, that is massive. It contains every ocean, every mountain range, and every city ever built. If you were to get into a commercial airplane and fly non-stop around the equator, it would take you about 2 full days of constant travel. That feels like a long time. It is a distance that commands respect in our minds. Yet, compared to the distances we are about to discuss, the Earth is effectively a single point. Even the gap between us and our closest neighbor, the Moon, begins to strain our human-scale perspective. The Moon is about 384,000 kilometers away. That is roughly 30 Earths laid side by side. If you could somehow drive a car to the Moon at highway speeds, it would take you about 6 months of driving 24 hours a day without a single stop for gas or rest. 6 months. That is half a year of your life spent just crossing the empty space between us and the nearest object in the sky. This comparison isn't perfect, but it gives us a calm place to begin. It reminds us that even near things in space are incredibly far by human standards. And yet, light crosses that same 384,000 kilometer gap in just over 1 second. 1 second. In the time it takes you to draw a single breath, a beam of light has already completed the journey that would take you half a year to drive. This is the first hint of the staggering efficiency of light, and the first clue as to why we need a new way to measure the universe. As we sit here, grounded and safe, we can begin to appreciate the stillness of our own scale. We live in the realm of centimeters, meters, and kilometers. We live in the world of the now, where we assume that when we see something, it is happening exactly as we perceive it. If a friend waves at you from across the street, you see them instantly. There is no lag, no delay that our senses can detect. But as we step further out, we will find that the universe has a speed limit, and that limit creates a bridge between distance and time. Imagine for a moment a vast, empty field. If you stand on one side and a friend stands on the other, and you both hold powerful flashlights, the light from their lamp seems to hit your eyes the exact moment they click the switch. On this scale, light is effectively infinite. It moves so fast, 300,000 kilometers per second, that it feels like a magical, instantaneous presence. Our ancestors, looking up at the stars, likely felt the same way. To them, the stars were just lights on a dome, distant but present, shining their light upon the earth without any sense of travel time. But the reality is more patient. The universe is more deliberate. To understand the light year, we must accept that every piece of light we see is a traveler that has survived a long, lonely journey. Even the light from the sun, which warms your skin on a summer afternoon, is a traveler. The the sun is 150 million kilometers away. That is a distance so large that the highway driving analogy breaks down. It would take you 150 years to drive there. You would be born, live your entire life, and pass away behind the wheel before you even made it halfway. And yet, for light, this journey takes only 8 minutes and 20 seconds. When you look at the sun safely, through a filter, or at sunset, you are not seeing it as it is now. You are seeing it as it was 8 minutes ago. If the sun were to vanish this very instant, we would continue to feel its warmth and see its light for nearly 9 minutes, blissfully unaware of the change. We are always living in the recent past of the stars. This realization is our first step toward letting go of our human scale perspective. We are moving from a world where everything is here and now to a universe where here is separated by vast thens. It is a shift from the concrete to the expansive. But do not let this make you feel small in a way that is cold or frightening. Instead, see it as a form of cosmic grace. The universe is so large that it allows us to see into the past simply by looking up. It provides us with a history book written in photons. As we prepare to leave the human scale behind and enter the first of our scale loops, take a moment to appreciate the sturdiness of your surroundings, your chair, the walls, the gentle rhythm of your breathing. These are your anchors. They are the zero on our cosmic ruler. From this safe, quiet vantage point, we are going to slowly extend that ruler, 1 light second, 1 light minute, and eventually 1 light year at a time. There is no rush to get there. The stars have been waiting for billions of years. They can wait a few more hours for us to arrive. For now, just hold on to the image of that single beam of light, leaving the sun, traveling through the cold dark for 8 minutes, and finally reaching the earth to illuminate a single leaf or a single window. It is a long way to go for such a small thing, but the universe is full of such journeys. With that in mind, let's move outward once more, to an even larger scale. We are leaving the comfort of the minutes and hours we know, and entering the realm where light begins its true marathon. To understand why we must abandon the kilometer and the mile, we have to look at the sheer inadequacy of our everyday numbers when applied to the celestial void. If we were to stay within our human scale perspective, the numbers would soon become so long that they would lose all meaning, becoming a mere blur of zeros that the mind instinctively ignores. This is why the light year exists, not just as a unit of measurement, but as a bridge for our imagination. Consider, for a moment, the distance across our own planet once more. If you were to take a standard ruler and try to measure the distance from New York to Tokyo, you could technically do it. The number would be in the millions of centimeters, perhaps, but it would be a number you could still write down on a piece of paper. But as soon as we point that ruler toward the sky, the scale shifts in a way that is almost humorous in its disproportion. Our world, with all its vast oceans and towering peaks, is effectively a grain of sand in a desert that has no end in sight. When we speak of human scale perspective, we are also speaking of human scale time. We measure our lives in decades. We measure our history in centuries. To us, 1,000 years is an unimaginably long time, 10 times the length of a long human life. It is the span of empires. Yet, in the context of the distances light must travel, 1,000 years is barely a heartbeat. To understand the light year, we have to marry these two concepts: the distance light covers and the time it takes to do it. It is a measurement that forces us to realize that looking out is the same as looking back. If you were to stand on a hill and look at a mountain range 50 kilometers away, you are seeing those mountains as they were a tiny fraction of a second ago. The delay is so small, roughly 0.00016 seconds, that your brain treats it as instantaneous. This is the comfort of the human scale. Everything we see is now, but as we move outward, this now begins to stretch and tear. By the time we reach the edge of our solar system, the now has become hours. By the time we reach the nearest stars, the now has become years. This is the human scale anchor slipping away, allowing us to drift into the deep drift phase of cosmic understanding. Imagine you are standing in a perfectly dark, quiet room. In the center of the room is a single candle. The light from that candle reaches the walls almost immediately. Now, imagine that room expanding. The walls move back miles, hundreds of miles, millions of miles. The candle remains in the center, a tiny, flickering point of light. If you are standing at the far wall, you have to wait. You have to wait for those tiny particles of light to cross the dark. This wait is the essence of the light year. It is the patience of the universe. In our daily lives, we are used to things being fast or slow. A car is fast compared to a walker. A plane is fast compared to a car. But light is the ultimate speed. It is the speed limit of reality. Nothing can go faster. And yet, even at this ultimate, impossible speed, the universe is so vast that light appears to crawl. To a photon, the trip from one side of a galaxy to another is a marathon that lasts longer than the entire history of the human species. When we use the term light year, we are acknowledging this paradox, that the fastest thing we know is still far too slow to make the universe feel small. Scientists understand this scale because they have to. Without the light year, the maps of the stars would be cluttered with numbers so vast they would be impossible to use in calculations. Imagine trying to describe the distance to a galaxy in inches. The number would have more digits than there are stars in the sky. The light year is our way of simplifying the infinite. It is a human-scale word applied to a non-human reality. It is a way for a creature that lives for 80 years to talk about a universe that has existed for 13 billion. As we settle deeper into this exploration, let the familiar world fade. The roads, the clocks, the schedules of tomorrow, they all belong to the scale of meters and minutes. Here, in the quiet expanse of the script, we are moving into the scale of the light year. This is a place where a short distance is trillions of kilometers. A place where recently means a few centuries ago. It is a safe place to be, because in this vastness, the small pressures of our lives find their proper perspective. They are not erased, but they are framed by a silence that has lasted for eons. Think of the light year as a long, steady breath. It is the distance light travels while the Earth makes one full trip around the Sunday. While you experienced 4 seasons, while you celebrated a birthday, while the trees grew and the snow fell, a beam of light was moving through the void, never stopping, never slowing, covering 9.5 trillion kilometers. It did this while you slept, while you worked, and while you dreamed. Every year of your life, light has added another light year of distance to its journey. This is the perspective we will carry with us as we move into our first scale loops. We will start with the small delays, the seconds and minutes, and gradually build our way up to the years, the centuries, and the millennia. We are not just traveling through space, we are traveling through time. And we are doing it together, safely anchored by the sound of this narrative. There is no need to hurry. The distance is already there, waiting for us to acknowledge it. The human scale perspective is our starting point, our home base. It is the familiar that we will return to at the very end. But for now, we are going to let the anchor lift. We are going to let the shore of the familiar world recede until it is just a tiny, pale blue dot in the rearview mirror of our imagination. We are moving into the realm of the light year, where the distance truly begins to blow our human minds, not with noise or chaos, but with a quiet, breathtaking vastness. And for now, that uncertainty of how we fit into such a large map is simply part of the picture. It doesn't need to be resolved tonight. We are simply moving outward, step by step, light second by light second, into the beautiful dark ocean of the cosmos. Now, let's slowly expand outward. One level beyond what we just explored lies the speed of light itself. To grasp the distance of a light year, we must first become intimately acquainted with the traveler that defines it. Scientists understand a light year by observing the fastest thing in the universe. Light travels at about 300,000 kilometers every single second. This is a speed that defies our biological wiring. In the time it takes you to blink a mere fraction of a second, a beam of light has already circled the Earth 7.5 times. It is a speed that seems instantaneous to our human senses, yet in the grand architecture of the cosmos, it is the fundamental yardstick by which all things are measured. When you flip a switch in your home, the room is filled with light immediately. There is no perceived delay between the movement of your hand and the illumination of the walls. For all intents and purposes in our daily lives, light is omnipresent. But as we step away from our atmosphere and into the vacuum, we realize that light is not a state of being. It is a physical entity moving through space. It has a beginning, a middle, and an end to its journey. It is a constant, unwavering pulse that dictates the very rhythm of reality. To visualize this speed, imagine you are standing at the start of a long, straight track that stretches into the horizon. If you were to fire a laser beam down that track, by the time you could even begin to process the flash of the light, that beam would be thousands of kilometers away. If we compare this to our human-scale anchor, the disparity is almost humorous. A commercial jet travels at about 900 kilometers per hour. A beam of light travels at over 1 billion kilometers per hour. If you were to race the two, the jet would appear to be standing perfectly still, frozen in time, while the light vanished into the distance. What makes this strange is not just the speed, but the fact that this is the absolute limit. Astronomers didn't expect to find a universe with a hard speed cap, but nature has provided one. No matter how much energy you use, no matter how powerful your engine, you can never overtake a beam of light. It is the gold standard of the universe. And yet, even at this impossible velocity, the universe is so vast that light often appears to crawl. This is the central paradox of cosmology. The fastest thing we know is still far too slow to make the universe feel small. Imagine a single photon, a tiny packet of energy, leaving the surface of a star. It has no mass, no weight, and it experiences no time. From the photon's perspective, its journey from the center of the galaxy to your eye is instantaneous. But for us, standing on this small blue planet, we must wait. We must wait for years, centuries, or even millennia for that photon to complete its trek across the void. This waiting is what defines our perspective. It is why we cannot talk about distance in space without also talking about time. A light year is the marriage of the two, the distance covered in the time it takes the Earth to orbit the Sun once. As you listen to these words, think about the light in the room again. It feels now, but it is actually a few nanoseconds old. When you look at the person sitting across from you, you are seeing them as they were a billionth of a second ago. On Earth, this doesn't matter, but as we move outward, the lag becomes meaningful. If you were to stand on the moon and shine a laser back at Earth, it would take 1.3 seconds to arrive. If you were having a conversation with someone on the moon, there would be a gentle, rhythmic pause between every sentence, a 1.3-second gap that you could never bridge. This delay is the first layer of the deep drift. It is a reminder that the universe has a built-in latency. We are always looking at the past. The further we look, the deeper into history we descend. This challenges how we think about the present moment. Is there even such a thing as now for the entire universe? Plus, or is now just a local experience, limited by the speed at which information can travel? Scientists have spent centuries debating this, and yet the mystery remains as calm and quiet as the stars themselves. Consider the Voyager spacecraft, the furthest human-made object. It has been traveling for decades, moving faster than any bullet ever fired. Yet, if we were to send a light signal to Voyager today, it would reach the craft in less than a day. Light covers in hours what it takes our best technology half a century to achieve. This is the scale of the marathon light is running. It is a constant, tireless sprint across a stadium that has no walls. But even with everything we've learned, there are still things we don't fully understand. We don't know why light moves at this specific speed. Why 300,000 kilometers per second? Why not more? Why not less? It is one of the fundamental constants of nature, a number woven into the fabric of space-time itself. It doesn't need to be explained or justified. It simply is. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. As we settle into this scale, let your mind rest on the idea of the light second. It is a distance of 300,000 kilometers, nearly 10 times the circumference of the Earth. It is a massive distance, yet it is only 1/62nd of a light minute, and a light minute is but a tiny fraction of a light year. We are building a tower of scale, and the light second is just the foundation. Imagine you are a traveler made of light. You leave the Earth behind. In 1 second, you have passed the moon. In 2 minutes, you are passing the inner planets. In 8 minutes, you reach the Sunday. 12. You are moving so fast that the planets appear like stationary marbles in a vast, dark room. But as you look ahead, you realize the room is much larger than you thought. The next nearest object is not minutes away. It is not hours away. It is years away. This is where the true scale of the light year begins to reveal itself. To cover the distance of 1 light year, you would have to maintain this 300,000 kilometer per second pace for 31,536,000 seconds. Every second another 300,000 kilometers. Every hour, another billion kilometers. Day after day, month after month, for an entire year. By the end of that journey, you would have traveled nearly 9.5 trillion kilometers. That is 1 light year. If we tried to use kilometers to describe the distance to the nearest star, we would be talking about 40 trillion kilometers. The numbers become a noise, a static that our brains cannot process. But 4.2 light years is something we can hold. It is a duration. It is the length of a high school education. It is the time it takes for a toddler to become a student. It gives the distance a human heartbeat. As you drift closer to sleep, imagine these beams of light crossing the void. They are silent. They do not carry heat across the vacuum. They are just pure information, pure energy, traveling through a cold, dark expanse that is mostly empty. The universe is not a crowded place. It is a series of very small lights, separated by very large silences. The light year is the measurement of that silence. We are moving outward now, leaving the realm of the light second and the light minute. We are entering the space where the light year becomes the only sensible way to speak. It is a transition that feels inevitable, like the slow turning of the tide. You don't need to do anything. You don't need to solve any equations. Just let the speed of light become the background rhythm of your thoughts. The universe moves slowly over immense spans of time, even when it is moving at the speed of light. And for now, that uncertainty, that vastness, is simply part of the picture. It is a safe place to be. You are here, in your bed, while the light is out there, doing the work of bridging the distances for you. With that in mind, let's move outward once more, to an even larger scale, beyond the speed of light, beyond the inner solar system, and toward the gaps that define our place in the galaxy. We are now entering the territory where the human scale anchor no longer just slips. It vanishes entirely. To understand the transition from the speed of light to the distance of a light year, we have to look at the sheer, overwhelming volume of the vacuum. Imagine for a moment that we could drain the universe of all its stars, all its planets, and all its dust. What remains is the canvas upon which light performs its marathon. This canvas is so vast that even at 300,000 kilometers per second, light is not a flash. It is a slow, steady pulse, a lonely traveler crossing a desert that has no markers. As we drift further from the sun, we begin to encounter the true nothingness that defines the cosmos. In our daily lives, empty usually means a room without furniture or a glass without water. But in the space between the stars, empty is a profound, almost mathematical purity. There are regions of space where you could travel for a light year, 9.5 trillion kilometers, and encounter fewer atoms than you would find in a single grain of sand. This is the low-density reality that light must navigate. When we say that a star is 4 light years away, we aren't just saying it's far. We are saying there is a 4-year-long gap of absolute, freezing silence between us and that distant fire. Scientists understand this by calculating the look-back time. This is a concept that acts as a verbal dissolve between the present and the past. Because light has a fixed speed, every distance in the universe is also a measurement of history. If you look at an object that is 1 light year away, you are seeing it exactly as it appeared 365 days ago. You are not looking across space so much as you are looking through time. This challenges how we think about the reality of the now. In the deep drift of the galaxy, there is no simultaneous moment. Each star exists in its own bubble of time, sending out messages that will not be received for years, decades, or centuries. Consider the sheer scale of a single light year once more. To visualize 9.5 trillion kilometers, imagine the distance from the Earth to the Sun, that 8-minute journey we discussed earlier. Now, take that distance and stack it end to end, 63,000 times. That is 1 light year. It is a distance so long that if you were to represent the Earth-Sun distance as 1 inch, a single light year would still be over a mile long. And remember, the nearest star is over 4 of those miles away. This is the scale expansion that begins to blow the human mind. We aren't just moving away from home, we are moving into a geography that refuses to be tamed by our standard maps. What makes this strange is not what we see, but what we don't understand about the nature of the vacuum itself. Astronomers didn't expect to find that space is expanding, a discovery that adds a layer of quiet complexity to our journey. As light travels its 9.5 trillion kilometers every year, the space it is traveling through is itself stretching, very slightly, every second. It's as if the marathon track is growing longer while the runner is mid-stride. This doesn't affect our local neighborhood much, but over the immense periods of time that light spends in transit, it changes the very color and energy of the light itself. It is a slow, rhythmic stretching of reality that happens without hurry and without end. As you listen, let the rhythm of these numbers settle into your breathing. Ow, 300,000 kilometers per second. 18 million kilometers per minute. 1 billion kilometers per hour. These are not numbers to be feared or solved. They are simply the heartbeat of the vacuum. They represent the tireless work of the universe, moving energy from one place to another across the dark. You are safe in the knowledge that this process is constant. The speed of light does not falter. It does not tire. It is the one thing in the universe that remains exactly the same, no matter where you are or how fast you are moving. And for now, that uncertainty about why the universe is so large and why we are separated by such vast gulfs of time is simply part of the picture. It doesn't need to be resolved tonight. We can accept the silence of the light years. We can accept that the stars we see tonight are ghosts of their past selves, and that our own light is currently traveling outward, a faint signal crossing the void to reach eyes that won't exist for another million years. This is the cosmic continuity, the realization that we are all part of a single, slow-moving story. Imagine you are a photon that has just finished its first year of travel. You have covered 1 light year. You look back, and the sun is no longer a blinding disk. It has shrunk to a bright, steady point of light, one star among many. You look forward, and the destination still looks impossibly far away. There is no wind in space, no sound, and no resistance. You are simply falling through the dark at the maximum possible speed, a tiny spark of information in a cathedral of shadow. This is the essence of the scale loop. We expand our view, we realize the vastness, we accept the mystery, and then we move outward once more. To understand that, we need to step back and look at the human scale perspective one last time before it disappears completely. On Earth, we think of a year as a long time. It is a cycle of seasons, a series of memories. But to the universe, a year is just the time it takes for light to cross a tiny fraction of a galaxy. When we combine the two, the human year and the cosmic speed, we get the light year. It is our way of speaking the universe's language using our own alphabet. It is a gentle humility, acknowledging that while we may be small, we have found a way to measure the infinite. As we conclude this first scale loop, let the image of the light marathon carry you toward a deeper state of relaxation. The light is moving, but you are still. The universe is vast, but you are warm and safe. The distances are mind-blowing, but they are also orderly and predictable. There is a peace in the precision of the speed of light. It is the ultimate clock, ticking away the seconds across the trillions of kilometers. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We have reached the first marker on our journey. We have looked at the speed, we have looked at the distance, and we have accepted the delay. We are now ready to leave the inner solar system behind for good and look at the objects that wait for us in the deep, quiet dark of the interstellar gaps. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond the speed of light lies our own neighborhood, the solar system. To truly grasp the weight of a light year, we must first look at the smaller, more intimate delays that happen right here in our own backyard. We often think of our solar system as a single, cohesive unit, a family of planets huddling around a central fire. But even within this family, the distances are so great that light, the fastest messenger in existence, begins to show the first signs of its struggle against the void. This is where we first encounter the lag of reality, a gentle reminder that nothing in the universe happens in a true, synchronized now. What we know so far suggests that the moon is about 384,000 kilometers away. To our human scale perspective, this is a massive distance, a journey that took the Apollo astronauts 3 days of intense travel to complete. But for light, this gap is merely a brief pause. When you look up at the moon tonight, you are seeing it as it was 1.3 seconds ago. It takes that long for the sunlight bouncing off the lunar surface to reach your eyes. This is the lunar delay. It is a small, almost imperceptible gap, but it is the first crack in the illusion of an instantaneous universe. If a large boulder were to roll across the lunar plains, or if a meteorite were to strike the surface, you would remain unaware of it for over a second. You are always watching a slightly delayed broadcast of our nearest neighbor. As we move past the moon, the seconds begin to turn into minutes. The sun, the very engine of our lives, sits much further away, about 150 million kilometers. This is the distance astronomers call an astronomical unit, or 1 AU. It is the gold standard for measuring our local neighborhood. Yet, even light needs time to cross this threshold. It takes 8 minutes and 20 seconds for a photon to travel from the surface of the sun to the Earth. If the sun were to suddenly go out, we wouldn't know it for 8 minutes. We would continue to live in its warmth and light, unaware that its source was already gone. Children would keep playing in the park, solar panels would continue to generate power, and the world would remain bright, all while the sun itself was already dark. We would continue to orbit a ghost of a star for those final 8 minutes. This comparison isn't perfect, but it gives us a calm place to begin. It shows us that even the most fundamental things in our lives, the very light of day, are subject to the patient laws of cosmic distance. Scientists understand these delays by observing the movement of the planets. When we send rovers to Mars, for instance, we cannot drive them in real time with a joystick. Depending on where Mars and Earth are in their orbits, the light delay can be anywhere from 3 to 22 minutes. If a rover is heading toward a cliff, the signal telling it to stop takes minutes to arrive, and the confirmation that it has stopped takes another few minutes to return. We are forced to communicate with the solar system through a veil of time. We are always talking to the past version of the planets, and they are always responding to a past version of us. But even with everything we've learned, there are still things we don't fully understand about how these distances affect our perception. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. To understand the scale, imagine you are standing in a vast, dark forest. You have a friend standing a few hundred yards away with a bell. When they ring the bell, you hear the sound a moment later because sound travels slowly. In the solar system, light is like that bell. It is incredibly fast, but the forest is so big that the sound of the light still takes time to reach your ears. As we drift further out to the gas giants like Jupiter and Saturn, the minutes turn into hours. When we look at Jupiter, we are seeing it as it was 40 minutes ago. When we look at Saturn, the light has been traveling for over an hour. If you were to watch the beautiful rings of Saturn through a telescope, you are seeing them not as they are in this moment, but as they were while you were perhaps finishing your dinner or starting this very script. The universe is a series of nested time capsules, each one holding a slightly older version of reality. This brings us to a quiet realization. We are never truly in the present when we look at the sky. We are observers of history. The light minutes that separate us from the planets are the first steps toward the light years that separate us from the stars. It is a gradual expansion of the now until it becomes so thin that it disappears entirely. In our daily lives, we measure time in seconds, minutes, and hours. But in the solar system, we begin to see that time and distance are the same thing. 1 AU is not just 150 million kilometers, it is also 8 light minutes. The distance is the time. Astronomers didn't expect the solar system to feel so empty, yet the gaps between the planets are far larger than the planets themselves. If you were to shrink the sun to the size of a grapefruit, the Earth would be a tiny grain of sand about 50 feet away. Jupiter would be a cherry about 2 blocks away, and the nearest star, that grapefruit, would be thousands of miles away. This is why we need the light year. Kilometers are too small to bridge the gaps between the fruits in our cosmic orchard. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's great red spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*. a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies, we are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth, Unmer. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light-years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. To understand the cosmos, we first have to understand our own limitations. We evolved to perceive distances we can walk in a day, or see with our own eyes distances that matter for survival and navigation. A kilometer is a 10-minute walk. A mile is a 20-minute journey. These measurements are concrete and relatable because they fit into our daily lives. But the moment we look up, these human-scaled units become awkward and eventually useless. To explore the universe, we must leave behind the familiar and prepare for a scale that challenges our very ability to comprehend it. Our brains are essentially biological survival machines, fine-tuned over millions of years to solve problems on a local scale. When our ancestors stood on the African savanna, big meant the distance to the horizon or the height of a mountain. Fast was the speed of a sprinting predator or a falling stone. We developed a deep, intuitive relationship with the physical world, but it was a world restricted to a very narrow band of reality. This is our human-scale anchor. It is the comfort zone of the tangible. In this zone, we can estimate how long it takes to drive to the next city, or how many steps it takes to cross a room. We feel the weight of an object in our hands and know its mass. This grounding is necessary for life on Earth, but it acts as a mental barrier when we attempt to look beyond our atmosphere. Consider the humble meter or yard. These units are literally based on the human body, the length of a stride or the reach of an arm. When we use these units to measure a house or a street, they make perfect sense. Even when we scale up to the size of our planet, we can still, with effort, visualize it. We can imagine a flight across the ocean taking 12 hours, and our brains can loosely stitch together that duration with the physical distance covered. We can look at a globe and understand that the thin blue line of the atmosphere is fragile, but even at this stage, the anchor begins to drag. The Earth is roughly 12,742 kilometers in diameter. If you were to try to walk that distance without stopping, it would take you months of continuous movement. Already, the human scale is beginning to fray at the edges. The problem is that the universe does not operate on a human scale. It operates on a cosmic one. As soon as we leave the surface of our world, the numbers don't just get larger, they change in quality. They become abstract. When we say the moon is 384,400 kilometers away, the brain hears the number, but it cannot feel the distance. It loses the tactile connection it has with a kilometer-long walk. This is the lunar gap, the first true test of our ability to let go of our terrestrial anchors. To bridge this gap, we often use analogies, telling ourselves that you could fit 30 Earths in the space between us and the moon. We use these mental crutches because the raw data is too vast for our ancestral hardware to process. We are trying to run cosmic-scale software on hunter-gatherer hardware. This limitation isn't just a quirk of psychology, it's a fundamental challenge in how we communicate the story of space. If we cannot relate to the distance of our nearest neighbor, how can we hope to grasp the distance to the sun? The sun is 150 million kilometers away. At this point, the kilometer has become a redundant tool. Using it to measure the solar system is like trying to measure the width of the Atlantic Ocean using the thickness of a human hair. It is technically possible, but the resulting number is so large that it ceases to mean anything to the human mind. This is why we must transition into new units of thought. We have to learn to think in terms of light-time understanding that even at the fastest speed allowed by the universe, it still takes 8 minutes for a photon to travel from the sun to your eyes. By anchoring ourselves in the human experience first, we acknowledge our starting point. We admit that we are small, that our perspective is local, and that our intuition is often wrong when applied to the stars. This humility is the prerequisite for discovery. We must accept that our senses were never designed to perceive the curvature of space-time or the billion-year life cycles of stars. We are effectively scale blind. Just as a person born without the ability to see color must rely on instruments to tell them the sky is blue, we must rely on mathematics and technology to tell us the true dimensions of the void. The human anchor is also about time. We live for perhaps 80 or 90 years. To us, a decade is a significant portion of our existence. A century is ancient history. But in the cosmic script, a million years is a blink. The stars we see at night are not static. They are in violent, constant motion. but because their lives span billions of years, they appear frozen to our short-lived eyes. Our anchor in time is just as restrictive as our anchor in space. We view the universe as a still photograph, when in reality it is a chaotic, high-speed film. To understand space-themed stories, we have to mentally speed up our perception of time while slowing down our expectation of distance. Every story we tell about the stars is an attempt to pull the cosmos down to our level. When we talk about interstellar travelers or galactic empires, we are using human political and social structures to make the infinite feel intimate. We give names to constellations, warriors, queens, and animals to turn a terrifyingly vast vacuum into a familiar neighborhood. This is a necessary survival mechanism. Without the human anchor, the sheer scale of the universe would be paralyzing. It would be a total perspective vortex that could crush the human spirit under the weight of its own insignificance. But there is a beauty in this struggle. The fact that a creature whose world is measured in footsteps can calculate the mass of a black hole or the age of a distant galaxy is a testament to the power of the mind to transcend its biological limits. We are anchored to the Earth by gravity and to our history by evolution, but our curiosity is unanchored. We use the familiar, the walk, the mile, the minute as a springboard to leap into the unfamiliar. We build mental ladders, starting with the human scale and slowly adding rungs of increasing magnitude until we can reach the stars. As we move forward into the deeper segments of the cosmic story, keep this anchor in mind. It is your point of reference. Every time we speak of a distance that breaks the brain, remember that it only breaks the brain because the brain was built for the forest and the field, not the vacuum. By recognizing the boundaries of our internal map, we can finally begin to explore the territory that lies beyond the edges. We are the bridge between the microscopic and the macroscopic. We are the observers who give the scale a name. In the following segments, we will leave the shore of the familiar. We will watch the Earth shrink until it is nothing more than a pale blue dot, and then we will watch that dot vanish entirely. We will see structures so large that they defy the cosmological principle, and we will encounter anomalies that suggest our current maps are incomplete. But no matter how far we travel, we always carry the human anchor with us. It is the "you are here" marker on the map of the infinite. It is what allows us to say, "I am small, but I am here, and I am looking." This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And, more importantly, where do we fit in? The journey starts here with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. To begin this expansion of our perspective, we must look at the tools we use to hold on to our reality. Think about your home. The average house is a space you can walk across in 30 seconds. You know the texture of the walls, the creak of the floorboards, and the exact distance from the front door to the kitchen. This is your primary anchor. It is a scale that makes perfect sense to your brain because you experience it every second of every day. Your brain evolved to understand these immediate, tactile spaces, areas you can see, touch, and navigate without a second thought. But when we move from the living room to the city, the anchor begins to slip. We start relying on technology, like cars and maps, to bridge the gap between what we can see and where we need to go. We are already abstracting our reality. The problem is that the leap from a city to a planet is nothing compared to the leap from a planet to the void. Imagine standing on a football field. It's about 360 feet long, a distance you could stroll across in 2 minutes. Now, imagine laying 17 of those fields end to end. That is a mile. Kilometer. A mile is a distance most of us can still visualize. It's a 20-minute walk, a common measurement for a morning jog. But to reach the edge of our own atmosphere, you would need to stack 62 miles of those football fields vertically. This is the Kármán line, the invisible boundary where the sky turns to space. Even at this relatively short distance, our human intuition fails. We cannot see 62 miles up. We only see a blue haze that fades into black. This brings us to the lunar gap. The moon is our closest neighbor, sitting approximately 238,855 miles away. To a human brain, that number is just a digit on a page. To bring it back to the anchor, consider this. If you could drive a car at highway speeds toward the moon, it would take you nearly 6 months of non-stop driving to get there. No red lights, no gas stations, just 160 days of driving through a vacuum. If you chose to walk, it would take you 9 years. This is the first rung on the cosmic ladder where the human scale starts to feel absurd. We use these analogies like fitting 30 Earths between us and the moon, not because they are scientifically precise, but because they are the only way to prevent our minds from shutting down in the face of such emptiness. Once we pass the moon, the anchor is no longer dragging, it is severed. The distance to the sun is 93 million miles. This is the solar anchor, the unit we call an astronomical unit, AU. If the moon was a 9-year walk, the sun is a walk that would take you 3,500 years. You would need 40 generations of your descendants to keep walking just to reach the light. This is why we stop using miles and start using light time. Light is the fastest thing in the universe, traveling at 186,000 miles per second. It can circle the Earth 7 times in a single heartbeat. Yet, even at this impossible speed, it takes light 8 minutes and 20 seconds to reach us from the Sunday. When you look at a sunset, you are seeing the sun where it was nearly 9 minutes ago. You are already looking into the past. This temporal shift is a crucial part of the human anchor. We are used to things happening now. If you drop a glass, It breaks now. If you call a friend, they hear you now. But in space, now is a localized concept. The further out we look, the further back in time we see. This creates a strange paradox. The larger the universe gets, the older the information we receive becomes. By the time we look at the nearest star system, Proxima Centauri, we are looking 4 years into the past. If that star were to vanish today, we wouldn't know for another 4 years. We are anchored in a present that doesn't exist for the rest of the cosmos. To understand the scale of a galaxy like our Milky Way, we have to stretch the anchor until it breaks. Our galaxy is 100,000 light-years across. If you were to scale the entire Earth down to the size of a single grain of sand, the Milky Way would still be the size of the entire United States. Think about that for a moment. Every mountain, every ocean, every city, and every person who has ever lived, all shrunk into one speck of sand, and the neighborhood it lives in is still a continent wide. This is the true scale that makes Earth disappear. We aren't just small, we are mathematically insignificant in terms of volume. And yet the Milky Way is just a mid-sized galaxy. When we look at giants like IC 1101, which is 6 million light-years across, the Milky Way itself becomes the grain of sand. IC 1101 is so large it could swallow thousands of Milky Ways. It is a cosmic monster, a graveyard of galaxies that have been consumed over billions of years. At this scale, the human anchor is so far behind us that it's almost impossible to find. We are talking about structures that take millions of years just for a single particle of light to cross. If you were on one side of IC 1101 and sent a hello message to the other side, by the time it arrived, your entire species might have evolved into something else or vanished entirely. But why does this matter to us, the observers? It matters because it defines the cosmological principle, the idea that on a large enough scale, the universe looks the same everywhere. But our recent discoveries of defiant anomalies suggest this might not be true. We have found structures like the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure is so large it shouldn't exist according to our current models of how the universe grew. It is a knot in the fabric of space that defies the smoothness we expected. These are the things that keep astronomers awake. They are the moments where our mathematical anchors fail, and we realize that the universe is even stranger than we imagined. We also encounter interstellar visitors like 3I, Atlas, or Oumuamua objects that don't belong to our sun. They come from the dark, silent reaches between stars, carrying secrets of other worlds. When we see these objects, the human anchor feels a different kind of tug. It's not just about size, it's about loneliness. We look at these drifting rocks and wonder if they were once part of a system like ours, or if they are the cold spots of a distant, dying sun. They remind us that our solar system is not a walled garden, but a porch light in a very dark forest. The human anchor is also a shield against the vast empty. Between the galaxies lie the voids, spaces, millions of light years across where there is almost nothing. No stars, no planets, just a few stray atoms per cubic meter. If you were placed in the center of the Boötes void, you wouldn't see a single star in the night sky. It would be total absolute darkness in every direction. For a creature evolved to follow the sun and the moon, this kind of emptiness is a sensory nightmare. Our anchor helps us populate that darkness with meaning. We look at the Great Attractor, a mysterious gravitational anomaly pulling our entire region of space toward it, and we give it a name. We turn a terrifying physical force into a character in our cosmic story. Consider the smallness of our achievements. We have sent probes like Voyager 1 into the interstellar medium. It has been traveling for nearly 50 years at 38,000 miles per hour. In human terms, that is incredibly fast. In cosmic terms, it hasn't even left the front yard. It will take Voyager 40,000 years to reach the vicinity of another star. This is the reality of the distance that breaks our brains. We are a species that lives for decades, trying to conquer a universe that operates in eons. However, there is a flip side to this insignificance. If the universe is so large and we are so small, then the fact that we can understand it at all is a small miracle. We are an arrangement of atoms, carbon, nitrogen, oxygen forged in the hearts of dying stars. We are literally stardust that has come together in such a complex way that it can now turn around and study the stars that made it. The universe is looking at itself through our eyes. When we calculate the distance to a quasar or the mass of a supermassive black hole, we are the universe's way of knowing itself. The human anchor isn't just a limitation, it's a perspective. Without the anchor, size has no meaning. A galaxy is only big because we know what small feels like. The vacuum is only empty because we know what a crowded city street feels like. We provide the contrast. We are the yardstick by which the infinite is measured. Every space-themed story, whether it's about a journey to Mars or the collision of two galaxy clusters, is ultimately a story about us. It's about how our human hearts react to the cold, beautiful indifference of the stars. As we continue to explore, we must be prepared for our anchors to be tested again and again. We will find impossible stars that are older than the universe itself. We will hear strange signals from the deep that might be natural or might be something else. We will see giant circles in the sky that hint at events from before the Big Bang. Each time, we will try to drag our human-scale units, our kilometers and our miles out into the deep to make sense of it. And each time, they will fail us, forcing us to grow, to adapt, and to build a bigger anchor. The human anchor is our starting point, but it is not our destination. It is the solid ground we stand on before we take the leap. We must respect our limitations, but we must never be imprisoned by them. We are the bridge builders. We bridge the gap between the grain of sand and the galaxy. We bridge the gap between the 10-minute walk and the billion-year journey. So, as we move into the next segments of this general script, as we look at the true scale, the light years, and the anomalies, remember the anchor. Remember the smell of rain on pavement, the warmth of the sun on your skin, and the simple reality of a 1-mile walk. Hold those things close. They are what make the vastness of space worth exploring. They are the reason we look up in the first place. We don't go into the dark to get lost. We go into the dark to find out just how bright our own small light truly is. We have grounded ourselves. We have acknowledged our size. Now, we are ready to leave the shore. The horizon is calling, and though it is further than it looks, we have everything we need to begin the crossing. The universe is vast, but it is also ours to observe. And that, in the end, is the most human anchor of all. When we think about the scale of the cosmos, we often imagine it in human terms. Distances we can walk, time we can measure in years or generations. Objects we can see with our own eyes and touch with our own hands. We like to think of a mile as a long way because, for most of human history, it was. If you lived in a medieval village, a trip to the next town was a significant life event. You would pack a bag, tell your neighbors goodbye, and hope the weather held. Your entire world was defined by the strength of your legs or the stamina of a horse. To a person living 1,000 years ago, the idea of a continent was an abstract myth, and the idea of a planet was simply a light that moved differently than the others in the night sky. This human-scale perspective is our biological inheritance. Our brains evolved to calculate the trajectory of a thrown stone or the distance to a fruit-bearing tree. We are optimized for the medium. We understand things that are roughly our size, moving at roughly our speed, living for roughly our duration. Because of this, when we hear a number like 1 million miles, our brains perform a sort of polite fiction. We treat it like a very big mile, rather than a distance that fundamentally breaks the logic of our daily lives. But to truly drift into the scale of the universe, we have to gently acknowledge that these human measurements, inches, miles, kilometers, are like trying to measure the depth of the Pacific Ocean with a thimble. Let's try to bridge that gap with something familiar. Imagine you are standing on a long, straight road that stretches toward the horizon. This road represents the distance from the Earth to the Sunday. If you were to drive a car at a steady highway speed of 65 miles per hour without ever stopping for a red light or a coffee, it would take you about 163 years to reach the Sunday. Think about that for a moment. If your great-great-grandfather had started driving the day he was born and passed the steering wheel down through the generations, you, his descendant, would only just be arriving at the sun today. You would have spent 4 generations in a car just to cross the shortest meaningful distance in our solar neighborhood. And yet, on a cosmic scale, the sun is right next door. It is our immediate porch light. When we look at the moon, we see an object that feels close enough to touch, a silver marble hanging in the branches of a tree. But the gap between the Earth and the moon is a surprisingly spacious hallway. You could fit every single planet in our solar system, Jupiter, Saturn, the ice giants, all of them into the space between the Earth and the moon, and you would still have a bit of room left over for a few dwarf planets. We see the moon as close because our eyes lack depth perception at that range, but in reality, it is a lonely outpost across 250,000 miles of silence. This brings us to the way we perceive time. We measure our lives in decades. We think of a century as a monumental span of time, the boundary of a long life, but the universe operates on a different clock. Astronomers often speak of millions of years as if they were afternoon naps. To a star, 1,000,000 years is a heartbeat. To a galaxy, 1,000,000,000 years is just a season. If we were to compress the entire 13.8 billion year history of the universe into a single calendar year, the entirety of human history, every war, every invention, every person you have ever loved would take up only the last few seconds of December 31st. we are a very new arrival in a very old house. It is helpful to remember that our ancestors once believed the stars were just small lamps hung from a ceiling. They believed the Earth was the heavy, unmoving center of everything. There is a certain comfort in that old view. It makes the universe feel like a room built specifically for us. It suggests that our scale is the correct scale. But as we have built better-eyes telescopes that can see the heat of newborn stars and the ripples of gravity, we have learned that we are living on a tiny, wet rock orbiting a middle-aged star in the quiet suburbs of a vast spiral galaxy. This realization doesn't have to be cold or frightening. In fact, for sleep, it is incredibly useful. If the universe is so vast and its timelines are so long, then the pressures of our 24-hour day begin to soften. The urgency of a deadline or the weight of a mistake begins to dissolve when placed against the backdrop of a star that has been burning steadily for 5 billion years. The universe is not judging your productivity. It is not waiting for you to finish your to-do list. It is simply there, continuing its slow, grand processes, regardless of our human-scale anxieties. Let's look at another comparison. Think of the fastest thing we know, light. Light travels at about 186,000 miles per second. At that speed, you could circle the Earth 7 times in the blink of an eye. It is the ultimate speed limit. Yet, even light, the fastest messenger in existence, takes 8 minutes to get from the sun to your skin. When you feel the warmth of the sun on your face, you are feeling energy that left its source 8 minutes ago. You are always living in a slightly delayed version of the past. As we move further out, this delay grows. If you look at the North Star, Polaris, you are seeing light that started its journey toward you around the year 1590. You are looking at the sky as it appeared when Shakespeare was writing his plays. The star could have vanished a century ago, and you wouldn't know for another few hundred years. This is the look-back time. It means that the deeper we look into space, the further we are looking back into history. The universe is a giant time machine, and we are the observers of ancient ghosts. Consider the physical size of our world. If you were to shrink the Earth down to the size of a single grain of sand, the sun would be about the size of an orange, located about 30 feet away. The nearest star to our sun, Proxima Centauri, would be another orange, located over 1,500 miles away. Between those two oranges, there is nothing but empty, dark air. This is the true nature of space. It is not a crowded room full of objects. It is a vast, echoing emptiness, where the objects are so small and so far apart that they almost don't matter. We often talk about navigating the stars, but for a human-scale traveler, the stars are effectively unreachable. If we sent our fastest current spacecraft to that nearest orange 1,500 miles away, it would take about 70,000 years to get there. That is 10 times longer than the entirety of recorded human history. We would have to survive through ice ages and the rise and fall of countless empires just to reach the very first doorstep of the cosmic neighborhood. This comparison isn't perfect, but it gives us a calm place to begin. It allows us to set aside our maps and our rulers. As you lie there, feel the weight of your body anchored to this one specific planet. You are a passenger on a world that is spinning at 1,000 miles per hour, orbiting a star at 67,000 miles per hour. While that star itself is racing around the center of the galaxy at 500,000 miles per hour. You are moving through the cosmos at incredible speeds, yet you feel perfectly still. This is the gentleness of the universe's scale. It provides a stable platform for life, even in the midst of a grand, celestial race. Now, take a slow breath. We are going to leave this human-scale perspective behind. We are going to stop thinking in miles and start thinking in nothing. We are going to step off the porch of our solar system and drift into the deep, dark water of the interstellar sea. The Earth is becoming smaller now. The sun is becoming just another point of light. The familiar shapes of the continents are blurring into a single, pale blue dot. And as it fades, the noise of the world fades with it. There is nothing you need to do. There is no one you need to be. You are simply a consciousness drifting through a very large, very quiet space. We are moving beyond the years and the miles. We are moving into the true scale. When we think about the scale of the cosmos, we often imagine it in human terms. Distances we can walk, time we can measure in years or generations, objects we can see with our own eyes and touch with our own hands. We like to think of a mile as a long way because, for most of human history, it was. If you lived in a medieval village, a trip to the next town was a significant life event. You would pack a bag, tell your neighbors goodbye, and hope the weather held. Your entire reality was defined by the horizon you could see from the top of the nearest hill. But to enter the true scale, we must gently set aside these terrestrial measurements. Imagine you are standing in a quiet field at night. To your eyes, the stars look like small, silver pins stuck into a velvet ceiling. They seem to exist on a single plane, just above the clouds. This is a beautiful illusion, a trick played by a brain that evolved to judge the distance of a predator in the tall grass, not the distance of a fusion reactor burning across a vacuum. In reality, there is no ceiling. There is only a series of staggering gaps that we have spent centuries trying to bridge with numbers that eventually stop making sense. Let's start with a distance we feel we understand, the journey across our own world. If you were to board a commercial jet and fly non-stop around the equator, it would take you about 2 days. It is a long time to sit in a pressurized cabin, but it is a manageable slice of a human life. Now, consider the distance to the moon. If you could drive your car upward at a steady highway speed of 65 miles per hour, it would take you about 6 months to reach the lunar surface. You would watch the seasons change through your windshield as you drifted through the silence. The Earth would shrink behind you until it was a bright, swirling marble, and the moon would grow until it filled your entire field of vision. This is the first step of the ladder, and already the scale is beginning to stretch our patience. But the moon is our closest companion, a mere 238,000 miles away. To reach the sun, our nearest star is a different order of magnitude entirely. If you maintain that same speed of 65 miles per hour, you wouldn't reach the sun for 163 years. You would spend your entire life behind the wheel, as would your children and your grandchildren. It would take 4 generations of your family just to arrive at the doorstep of our local star. When you feel the warmth of the sun on your face, remember that the energy touching your skin has crossed a gap that would take a human family over 1.5 centuries to traverse by car. This comparison isn't perfect, but it gives us a calm place to begin. It helps us realize that our units of measurement, the mile, the kilometer, the foot, are like trying to measure the volume of the Pacific Ocean with a thimble. They are tools for a smaller world. To navigate the true scale, astronomers use the speed of light. Light is the fastest thing in the universe. It moves at 186,000 miles per second. In the time it takes you to blink, light has circled the entire Earth 7 times. It is the ultimate limit of speed. Yet, even light takes 8 minutes to reach us from the Sunday. When the sun sets, you are seeing it where it was 8 minutes ago. You are always looking into the past, even when looking at your own neighborhood. As we move further out, the human scale perspective begins to fail completely. We think of the planets as being close to one another, but they are incredibly lonely. If the sun were the size of a bowling ball sitting in the middle of a city park, the Earth would be a tiny peppercorn located about 75 feet away. Jupiter, the largest of the planets, would be a grape located 2 city blocks away. Pluto would be a single grain of sand, nearly half a mile away in a different part of the city. Everything in between those tiny objects, the peppercorn, the grape, the grain of sand, is just empty air. This is the scale of the nothing. It is a quiet truth that the solar system is mostly just space, with a few small, cold rocks and gas balls scattered like accidents in the dark. Think about what this means for our sense of importance. On Earth, we argue over borders, we worry about our status, and we build monuments to our achievements. But from the perspective of the true scale, the entire history of humanity has taken place on a speck of dust that is invisible from the next town over in the cosmic city. This realization doesn't have to be cold. In fact, for sleep, it is a profound relief. If the universe is this vast, then the weight of your individual responsibilities can finally be set down. The stars are not waiting for you to be productive. The galaxies are not judging your progress. They are simply continuing their slow, elegant processes, indifferent to the small frictions of human life. Scientists understand this indifference by measuring the void between the stars. What we know so far suggests that if you were to stand in the middle of the space between our Sun and the next nearest star, Proxima Centauri, you would be in a darkness so deep that your eyes would struggle to find a point of reference. You would be 25 trillion miles from the nearest house. It is a distance so large that if you tried to count it out, 1 mile per second, it would take you 800,000 years just to finish the number. But even with everything we've learned, there are still things we don't fully understand. Astronomers didn't expect to find that the empty space between the stars is actually filled with a very thin, very hot gas, the interstellar medium. It is a vacuum more perfect than anything we can create in a laboratory, yet it contains the building blocks for future worlds, not because we're missing something urgent, but because the universe moves slowly over immense spans of time. For now, that uncertainty is simply part of the picture. As you drift further into your rest, imagine your perspective shifting. You are no longer looking up at the sky. You are looking out into an ocean. The Earth is a small, sturdy boat, and you are a passenger resting in the cabin. The waves are the ripples of gravity, and the distant lights are the fires of other suns. There is no need to steer. There is no need to check the map. The boat knows where it is going, following a path carved by the rotation of the galaxy over millions of years. Consider the age of the atoms that make up your body. We measure our lives in decades, But the iron in your blood and the calcium in your bones were forged in the hearts of stars that exploded billions of years ago. You are not a separate entity from the universe. You are a piece of it that has temporarily gathered in this specific form to observe the rest. When you close your eyes, you are not turning off the world. You are simply returning your attention to the internal quiet that matches the external quiet of the deep drift. The true scale of the universe is not just about size, it is about time. Every star you see is a ghost of its former self. You are looking at light that has been traveling for centuries. If a star 500 light years away vanished tonight, we would continue to see it shining in our sky for another 5 centuries. It would be a memory of light, a beautiful lie told by the vastness of the distance. This look-back time means that the deeper we look into space, the more we are looking into the history of everything. We are travelers in a time machine that only moves in one direction. This brings us to a sense of cosmic acceptance. If the universe is a collection of memories and distances that defy the human clock, then there is no reason to hurry. We can simply exist. Like a stone at the bottom of a deep, clear lake, we can let the water of time flow over us without being moved. The pressure of the world is a human scale pressure. The silence of the universe is the true scale. As we prepare to leave the human scale perspective behind, take a moment to appreciate the smallness of your room. It is a safe, warm pocket of existence in a cosmos that is mostly cold and empty. But remember that the walls of your room are made of the same atoms as the rings of Saturn. The air you breathe is part of the same atmosphere that once contained the breath of every person who has ever lived. You are connected to the whole. You are a small, quiet node in a network of light and gravity that stretches for 93 billion light years. And for now, that uncertainty, the question of why the scale is so large and why we are so small, is simply part of the picture. It doesn't need to be resolved tonight. You don't need to find the answer to the universe to find the way to sleep. You can simply accept the scale. You can accept the distance. You can accept that you are a consciousness drifting through a very large, very quiet space. With that in mind, let's move outward once more, to an even larger scale, beyond the years and the miles, to the places where the suns are just points of light and the nothingness is the only thing we can truly measure. Now, let's slowly expand outward. One level beyond what we just explored lies our immediate neighborhood, the solar system. We often see diagrams of the planets lined up like marbles on a table, neat and crowded. But the reality is much quieter. If you were to look at a standard textbook illustration of our solar system, you would see the Sun on the left, followed by Mercury, Venus, Earth, and Mars, all tucked neatly together. Then, perhaps a small gap for the asteroid belt, followed by the gas giants. These diagrams are useful for learning the order of the planets, but they are fundamentally dishonest about the space involved. They have to be. If a textbook were printed to scale, with the Earth the size of a pea, the book would need to be several miles wide to show where Neptune sits. Scientists understand the solar system by observing the gravitational dance of the planets, a choreography that takes place across vast stretches of nothingness. What we know so far suggests that the space between things is the most important part of the system. To truly understand this, we have to discard our maps and build a new one in our minds, starting with the Sunday. Imagine the sun not as a godlike entity of infinite size, but but as something we can relate to. Let's imagine the sun is the size of a large grapefruit. In this model, the Earth, our entire world, with its oceans, mountains, and all 8 billion of us, is a tiny, microscopic speck of dust located about 50 feet away from that grapefruit. To find Mercury, you would step only 20 feet away. Venus would be at 37 feet. At 50 feet, you reach our speck of dust. If you were to stand by that grapefruit sun and look toward the Earth, you wouldn't even be able to see it without a magnifying glass. Between the grapefruit and the speck of dust, there is nothing. No air, no sound, just the steady stream of light and solar wind. This is the inner neighborhood. It feels cozy because we are used to the idea of the inner planets. But even here, the emptiness is the dominant feature. If you were to walk from the Earth speck to the Mars speck, you would have to walk another 25 feet. But as we move further out, the scale begins to stretch. The gap between Mars and Jupiter is where the neighborhood starts to feel more like a wilderness. To reach Jupiter, our grape in this model, you would have to walk over 260 feet from the sunday. That's nearly the length of a football field. At this distance, the grapefruit sun is looking quite small in the distance. The warmth is fading. By the time you reach Saturn, you are 470 feet away. Uranus is 950 feet away. And Neptune, the final major planet, is nearly 1,500 feet away from our grapefruit. That is 5 football fields of distance. If you stood at Neptune and looked back, the sun would no longer be a grapefruit. It would be a tiny, brilliant point of light, no larger than any other star, though much brighter. This is the reality of our home. We live in a system that is 99.9% empty space. The planets are not neighbors in the sense of houses on a street. They are more like a few lonely ships scattered across a dark, silent Pacific Ocean. Scientists understand this emptiness by calculating the orbits of these bodies, which move with a predictable, clockwork precision. Yet, even with everything we've learned, there are still things we don't fully understand. For instance, we have discovered that the edges of our solar system are not as sharp as we once thought. Beyond Neptune lies the Kuiper Belt, a vast, dark donut of icy objects and frozen remnants from the birth of the system. We find strange objects in the Kuiper Belt that shouldn't be there, like Haumea, an object shaped like a football that spins so fast a day lasts only 4 hours. We find Eris, a world almost the size of Pluto, hidden in the shadows for centuries, because it was too far and too dim to see. There are even orbits of distant objects that seem to be tugged by something large and unseen. A planet 9 that may be 10 times the mass of Earth, lurking in the deep dark, 20 times further away than Neptune. Astronomers didn't expect to find such complexity in the nothingness beyond the planets. What makes this strange is not what we see, but what we don't understand about the gravity of the outer reaches. We can feel the ghost of a planet in the math, but our telescopes see only the black, not because we're missing something urgent, but because the universe moves slowly, and it reveals its occupants only when the light hits them just right. Think about the time it takes for anything to happen here. If you were to stand on the surface of Neptune, a single year, one trip around the sun, would take 165 Earth years. If you were born there, you would never see a single birthday. Your children and grandchildren would live and die before the planet moved back to the spot where you were born. This is the pace of the solar neighborhood. It is a slow, rhythmic progression that doesn't care about our frantic human calendars. And for now, that uncertainty, the missing planets, the dark rocks, the immense travel times, is simply part of the picture. It doesn't need to be resolved tonight. We don't need to know if Planet 9 exists to appreciate the balance of the system. We can simply accept that we are part of a giant, spinning mechanism that extends far beyond our ability to easily visualize. As you consider this, let your mind drift into that space between the grapefruit and the specks of dust. Imagine the silence of the asteroid belt, where most asteroids are so far apart that you could fly a spaceship through the middle of it and never see a single rock. Imagine the dim, blue light on the clouds of Neptune, where the sun is just a very bright memory. The solar system is our anchor, our familiar porch, but even this porch is enormous. It is the first step in a journey that will eventually take us to places where the sun itself is forgotten. But there is no hurry to get there. The gravity of the sun is still holding us. The rhythm of the orbits is still steady. We are safe in our neighborhood, even if the neighborhood is mostly made of shadows and stars. With that in mind, let's move outward once more, to an even larger scale, beyond the ice, beyond the Kuiper Belt, to the very edge of the sun's influence, to a place where the light of our star begins to fail and the true deep begins. As we transition from the familiar warmth of the inner planets to the frozen outskirts, we are entering a realm where the sun is no longer a dominant furnace, but a distant, brilliant pilot light. This is the boundary of the inner neighborhood, a place where the clock of the universe seems to slow down, and the distances between objects begin to swell like a rising tide. To understand this transition, we must first look at the Kuiper Belt. If the inner solar system is a bustling city center, the Kuiper Belt is the vast, icy tundra that lies just beyond the last train station. It is a region of space shaped like a giant, thick disk, populated by hundreds of thousands of icy bodies, remnants from the very earliest days of our solar system's formation. These are the leftovers of creation, frozen in a permanent state of preservation. Scientists understand this region by observing the way these small, dark objects reflect the faint sunlight that reaches them. What we know so far suggests that this belt extends from the orbit of Neptune, about 30 times further from the Sun than Earth, to about 50 times that distance. In this neighborhood, the primary resident is Pluto. For a long time, we thought of Pluto as the edge, the final, lonely outpost. But we now know that Pluto is just one of many Plutoids, small, icy worlds that inhabit this dark frontier. Imagine standing on the surface of Pluto. The sun would appear 1,000 times fainter than it does on Earth. It would be a point of light so intense it would still be painful to look at, but it would provide no warmth. The daylight on Pluto is equivalent to a deep twilight on Earth. It is a world of nitrogen ice and frozen mountains, where the atmosphere itself freezes and falls to the ground, like snow, as the planet moves further away from the sun in its long, oval orbit. But even with everything we've learned, there are still things we don't fully understand. Astronomers didn't expect to find that many of these distant objects have their own moons, or even complex geological activity. We found that Pluto has a heart-shaped glacier made of nitrogen ice that is constantly churning and renewing itself. not because we're missing something urgent, but because the universe moves slowly, and the heat of a planet's core can last for billions of years, even in the absolute cold of the outer reaches. As we move past the Kuiper Belt, we encounter the scattered disk. This is a more chaotic region where objects have been flung into strange, highly tilted orbits by the gravity of Neptune. It is a place of cosmic orphans, worlds that were bullied by the giant planets and sent into the wilderness. One of the most famous residents here is Eris, a world almost identical in size to Pluto but much denser. Eris is so far away that it takes 557 Earth years to complete a single trip around the Sunday. If you lived on Eris, your entire human history from the Renaissance to the digital age would take place in just one of your years. Scientists understand these orbits as a record of the solar system's violent past. They are the scars of a time when the giant planets were shifting their positions, throwing smaller rocks like gravel under the wheels of a heavy truck. What we know so far suggests that this region serves as a reservoir for comets. Every so often, the gravity of a passing star or the subtle nudge of the galaxy itself will send one of these icy rocks tumbling toward the inner solar system, where it grows a tail and becomes a spectacular visitor in our night sky. But out here, there are no tails. There is only the cold. This brings us to the heliopause, the true magnetic edge of the sun's domain. The sun does more than just provide light. It exhales a constant stream of charged particles called the solar wind. This wind creates a bubble around us called the heliosphere, which protects us from the harsh radiation of interstellar space. At the heliopause, this solar wind finally meets the interstellar wind and is pushed back. It is the boundary between the inside and the outside. In 2012, Voyager 1 became the first human-made object to cross this threshold. Scientists understood this crossing by measuring the density of the plasma around the spacecraft. What we know so far suggests that the transition is not a sharp wall, but a turbulent zone where the sun's influence flickers and fades. When Voyager 1 crossed over, it entered the stellar sea we discussed earlier, but it was still within the gravitational reach of the Sunday. This is a crucial distinction. The sun's light may fail and its wind may stop, but its gravity reaches out much, much further. Beyond the heliopause, we enter the inner Oort cloud, or the Hills cloud. We are now moving into a scale that defies the maps of the inner planets. If the distance from the Sun to the Earth is one step, we have now taken 30,000 steps. The Sun is now just a very bright star among others. The silence here is heavy. In the inner neighborhood, we have the music of the spheres, the rhythmic orbits of the planets. But here, the rhythm is so slow, it is almost undetectable. Consider the object known as Sedna. Sedna is a large reddish world that never comes closer to the Sun than 76 times the distance of Earth, and at its furthest point, it wanders nearly 1,000 times further away. It takes 11,000 years for Sedna to complete one orbit. The last time Sedna was at its closest point to the Sun, humans were just beginning to develop agriculture. The next time it returns, who knows what will be left of our civilizations? This is the pace of the outer neighborhood. It is a scale of time that turns our centuries into minutes. Astronomers didn't expect to find worlds like Sedna. Its existence suggests that there may be thousands of similar objects hidden in the deep dark, waiting to be discovered. What makes this strange is not what we see, but what we don't understand about how Sedna got there. It is too far out to have been affected by Neptune's gravity, yet it is too close to have been placed there by passing stars. Some scientists suggest it may have been captured from another star system entirely when the Sun was still in its birth cluster, not because we're missing something urgent, but because the universe is a place of ancient, slow-motion thefts and exchanges. As you drift here, let your mind fill with the image of these lonely, frozen sentinels. They are the guardians of the solar system's borders. They don't need the warmth of the sun to exist. They are perfectly content in the negative 400-degree cold of the deep drift. In your bed, you are wrapped in layers of fabric and the warmth of a room, but in your mind, you can experiment with the idea of being as still and as cold as Sedna. There is no shivering in the vacuum. There is only the absence of vibration. This is the phase of cosmic continuity, where the individual system begins to blend into the galactic background. We are still at home, but the house is so large that we can no longer see the walls. We are in the basement of the solar system, where the foundations are laid. It is a place of low density, where the matter is spread so thin that a traveler could go for 1,000 years without seeing anything larger than a grain of dust. Scientists understand this low density as the natural state of the universe. We are the anomaly. Our dense planet, our thick atmosphere, our crowded cities, these are the rare exceptions. The true scale of the universe is the scale of the Oort cloud and the scattered disk. It is a scale of vast, empty distances and immense waiting periods. But for now, that uncertainty is simply part of the picture. We don't need to know every resident of the Kuiper Belt to feel the safety of the sun's gravitational anchor. Even out here, at the very edge, the sun is still holding on. It is a faint, distant tether, but it is enough. You are still part of a system. You are still part of a family of worlds. Think of the deep drift as a form of meditation. In the inner solar system, there is so much to look at. The rings of Saturn, the volcanoes of Io, the storms of Jupiter. But in the outer neighborhood, there is only the quiet. It is the part of the video where the music slows down and the images become more abstract. It is the part of the night where the thoughts of the day have all been processed and there is nothing left to do but drift. We are moving past the years and the miles. We are moving beyond the need for landmarks. The Kuiper Belt is a fading ring behind us. The heliopause is a memory of a breeze. We are entering the true deep, where the distances between objects are measured in light months and light years. You are a consciousness drifting through a very large, very quiet space. There is no one to meet here. There are no appointments to keep. The orbits of these outer worlds are so long that they are essentially straight lines from our perspective. There is only the forward motion, the steady expansion of the distance between you and the world you knew. And as the light of our star begins to fail, we find that the dark is not something to be feared. It is simply a different kind of light, the light of the distant stars, the light of the galaxy, the light of the beginning of time. It is a light that doesn't burn, it only illuminates the scale. With that in mind, let's move outward once more, to an even larger scale, beyond the reach of our sun's gravity entirely, to the interstellar sea, where we are no longer residents of a solar system, but citizens of the Milky Way. And so the universe continues, expanding, cooling, changing slowly, quietly, endlessly. We have reached the final stage of our journey, the the moment where the script no longer seeks to guide your mind, but simply to exist alongside it. We have moved from the familiar steps of a human walk to the staggering distances of the light year, and finally to the very edge of the observable horizon. But as we settle into this infinite ending, we realize that there is no true boundary. The universe does not simply stop where our vision fails. It carries on, drifting into a future that is as vast and silent as the spaces between the galaxies. You don't need to stay awake for this part. The universe will still be here, moving gently forward long after this moment passes. Scientists understand that the story of the cosmos is one of profound endurance. What we know so far suggests that for the next several trillion years, stars will continue to be born in the glowing nurseries of gas and dust we call nebulae. Light will continue to be generated, and it will continue its tireless sprint across the vacuum. A photon, created in a star tonight, will begin a journey that may last long after our sun has cooled into a white dwarf. This is the ultimate cosmic continuity. The universe is not a project to be finished. It is a state of perpetual, slow motion, becoming. In this low-density explanation phase, we find that the light year remains the only constant. Even as space expands and the galaxies pull further apart, the speed of light remains 300,000 kilometers per second. It is the steady heartbeat of a universe that is otherwise growing increasingly quiet. Astronomers didn't expect to find such a lonely future for the cosmos, where eventually every galaxy will be an island, separated by so many light years of empty space that their light can no longer reach one another. But even in that distant, isolated future, the laws of physics will remain. The light will still travel. The silence will still be full. As you drift deeper into sleep, let the scale loop dissolve into a single, unified feeling of peace. We have seen the billions of years and the trillions of kilometers, and we have found that they are not something to be conquered, but something to be accepted. There is no urgency in a 13-billion-year-old sky. There is no tension in a distance that takes 1,000,000 years to cross. You are safely anchored in the infinite ending, a place where time and space merge into a single, soothing rhythm. Imagine the very last photon of a distant star finally reaching the edge of the galaxy. It has no destination, no observer. It simply moves. It is a part of the deep drift, the endless journey that requires no effort and no arrival. Your thoughts can do the same. They can let go of the need for conclusions. They can let go of the need for answers. In the presence of the infinite, the questions simply become part of the beauty. Think of the philosophical dissolution we explored. You are not separate from the light years. You are the consciousness that has emerged from them to look back and wonder. The same atoms that traveled through the dark for eons are now resting here, in your room, in your body. You are a quiet home for the universe. There is a profound humility in this, but also a profound strength. You belong to the continuity. You are as much a part of the infinite ending as the furthest quasar or the oldest star. The light year has taught us that distance is just time in another form. And time, as we see tonight, is something the universe has in abundance. There is enough time for everything to unfold. There is enough space for every star to find its place. As the darkness of the room matches the darkness of the interstellar gaps, let the boundary of your own mind soften. You are no longer measuring. You are no longer calculating. You are simply drifting. The universe moves slowly, over immense spans of time. It expands without hurry. It cools without protest. It is the ultimate example of a life lived in peace. As you close your eyes, remember that the light is still out there, crossing the miles, bridging the gaps, connecting the past to the future. You don't need to do anything to help it. You don't need to stay awake to witness it. The universe is perfectly capable of continuing on its own. This state of eternal movement is not a chaotic rush, but a predictable, rhythmic unfolding. We often feel that time is something we are running out of, a resource that must be spent or managed. But the light year teaches us that time is simply the medium through which the universe expresses its vastness, across distances that no longer fit neatly into numbers. Time is not an enemy, it is a bridge. It is the silence that allows the stars to be seen. It is the space that allows galaxies to breathe. Scientists understand that this infinite ending is characterized by a gradual thinning of reality. As space stretches, the density of the universe decreases, but this is not a loss. It is a transition into a deeper state of calm. Imagine a single drop of ink falling into a vast, clear lake. At first, it is concentrated and dark, but as it spreads, it becomes part of the water itself, thin, transparent, and all-encompassing. The universe is like that ink, slowly spreading its energy and its light until it becomes one with the silence of the void. This low-density explanation phase is the final destination for all the structures we have visited tonight. What we know so far suggests that even in the deepest future, the laws of the universe will remain unchanged. The speed of light will still be the limit. Gravity will still be the guide. The cosmic continuity ensures that the story doesn't end. It simply changes its tone. It moves from the high-energy fire of the first stars to the soft, cooling glow of the distant future. It is a transition from the noise of creation to the music of the infinite. You are a listener to that music. Your quiet presence in this moment is a reflection of the universe's own stillness. Astronomers didn't expect the universe to be quite so resilient. They found that even after the last star fades, the universe will continue to expand. The light years will keep growing. The distance will keep increasing. But because you have traveled this path tonight, you know that distance is not a barrier to belonging. You are connected to the very beginning of time by the light that has traveled for billions of years. You are connected to the furthest reaches of the cosmic web by the gravity that holds your world in place. You are a vital, permanent part of the scale loop. As you drift into the final layers of rest, let the philosophical dissolution be complete. You no longer need to hold on to the maps or the numbers. You can let the 9.5 trillion kilometers of a single light year drift away. You can let the 100,000 years of the Milky Way fade. You can let the billions of years of the cosmic history merge into the single, quiet now of your own breathing. The distance has been bridged. The time has been acknowledged. The light year has fulfilled its purpose. Imagine the universe as a vast, quiet ocean. You are floating on the surface, supported by the density of the water, looking up at a sky that has no end. There is no wind, no current, no noise. There is only the steady, rhythmic pulse of the stars, sending their light across the years to find you. You are the destination of a journey that began before the world was born. You are the recipient of an ancient, glowing message. You are home in the deep drift. The realization that the universe is infinite is the final reset for your mind. It means there is always more to explore, but there is also no rush to see it all. The stars will still be there tomorrow. The galaxies will still be there in 1 billion years. The infinite ending is a promise of continuity. It is a promise that the silence will always be there to hold you. And so the universe continues, quietly, endlessly, beautifully. It expands without hurry. It cools without protest. It is the ultimate example of a life lived in peace. You can follow that example. You can let your thoughts expand. You can let your mind cool. You can exist in this moment, safely tucked into the corner of a galaxy, while the light years do the work of holding everything together. And somewhere within all of this, we can begin again by starting with something familiar: the weight of your blankets, the rhythm of your breath, the soft, dark air of the room. These are your anchors. They are the human scale. And as you return to them, you carry the perspective of the infinite with you. You are a traveler who has seen the stars and who has found that they are not far away, but intimately connected to the very heart of who you are. Good night. The universe is moving gently forward, and you are moving with it. You are safe. You are part of the continuity. You are the infinite light. Good night. Ow. Good night.